Well, good morning, everybody. It's morning here in the Pacific Northwest of the United States, anyway. I'm located in Oregon. And from the looks of things, you guys are located in many parts of the world. Wherever you're from, welcome. And I sure hope you enjoy these sessions. First, I'd like to introduce myself. My name is Pat Barton. Just call me Pat. I have had the honor and privilege of teaching Python to students just like you for about 10 years. Actually, I jump in and out of teaching. I've had a variety of different positions and different roles that I think will serve well as we start talking about Python, because I'm a creature of the non-programming world. I'm mostly an economist, mostly a mathematical modeler, and actually I'm a scientist. I worked for 5 years with one of the United States National Energy Laboratories, where, among other things, I worked on a project to inform the US Congress about the dangers of global warming and what we can do about it. I hate to say this, but that was right around 1985, and we've done nothing about it. I've been in the Python world for 10 years, as I've said. I was a teacher at the O'Reilly School of Technology, and O'Reilly is the publishing company that makes all those computer books with animals on their covers. They started a school to teach calculus and open source software. I was the full course Python instructor there for 2 years. I was the dean of faculty for 1 year. Since then, I worked for ONLC, which is a big online learning company. I started my own code school, taught several classes through that. I've developed 4 Python courses, each going a week, along with the materials for them. I've been with Clarusway now for several months. I teach data analysis, data visualization, and Python. In my own life, one of my big projects right now is I've been building a Python-based intelligent snake trap to capture Burmese pythons, which are an invasive species, which are destroying the ecosystem in the Florida Everglades. In Florida, it's basically the south and eastmost tip of the United States. It's a big swamp. And a lot of people have had Burmese pythons for pets, and they've let them out, and they've gone and destroyed everything. And the pythons there are big enough to eat deer and alligators. Anyway, so I've got a patent on a device that uses Python, the language, to capture pythons, the invasive species. And I got a great talk. It's Python versus Python, saving the world at a time. So anyway, the combination of my teaching experience and real world experience, I think will serve you well through this class. Now, we have a lot of people. There are 20 something of you. So it's a lot of people, and I'm going to try to meet everybody's needs as we go through this, especially in the beginning, when it's important that you understand the basics and the setup and how to get help and that kind of thing. But whether we're at the beginning of the class or somewhere in the middle of it, and by the class, I mean all the sessions we have together, I would like you to feel free to ask questions. Okay? Now, a lot of people hesitate because they don't want to seem dumb. Well, I got to tell you, if you've got a question, probably somebody else does. And probably that other person is worried about feeling dumb. The other thing I would share with you is is that one of the things I do in life is I'm a Boy Scout leader. I guess you might call them guides in Europe. But anyway, I take groups of teenage kids out on 40-mile hikes over terrain, with 40-pound backpacks, and we stay out for a week at a time. And it's potentially really dangerous. Anyway, I tell all my kids that the dumb question is the question you don't ask. All right. And I really believe that. So just jump in. If I've explained something and you don't understand, it's probably my fault. Why? I didn't explain it well enough. All right. So jump in, grab me by the throat, say, tell us about that again. And I will. No problem. Okay. Any questions so far? All righty. So today what we're going to do is go through some real basics. I'll tell you what Python is. I'll show you some Python. And we'll show you how to install the tools that you'll need onto your machine. Okay, and by the time we're done with today's session, hopefully everybody will have a working version of Jupyter Notebooks. If you don't know what that is, don't worry about it right now. I'll tell you about them. And VS Code, which is a code editing platform. And you will be completely set to do your own Python programming, because as you'll see, Python is like really, really talkative, and it's got an awesome integrated help system. And you can ask it questions about itself, and it will answer those questions in context. Okay. All the objects in Python are fully functional to include a help system. So if you just say help object, it'll tell you all about it, and I'll show you what to do. Okay. Now,
okay.
I'm going to
and
a little.
But let me to say that thank you for your time and nice to meet you.
Pleasure to meet you too.
I want to say that. Thank you.
Thank you. Appreciate that feedback. I still have time to disappoint. I'll try not to. So today's session is called Python Basics. And just to give you an overview, we'll talk about what it is and how it fits in, how it's important. We'll talk about some of the reasons it's so cool and the reasons it's so popular. We'll talk a little bit about who uses it, and the answer to that is everybody. Okay. We won't go over too much of the history, but this is a really cool cat. He's the guy that invented Python, pretty much from scratch. Dutch dude. He loves to drink beer, and he's a good language architect. So we'll show you some of the tools. Okay, show you how to get them going, and then we'll finally get some coding. And I promise you, by the end of the day, you will have written your first Python program. All right. Now, I'll talk about some of the history and some of the fluffy stuff as we get going. First thing I want to do is make sure that everybody has Python on a platform on their computer that they can use. I'm going to recommend a couple of different tools and show you how to set them up. You don't have to use them. You don't have to. But I highly recommend them. I'm going to first look at Python or IPython notebook. It's called a Jupyter notebook these days. It's a way to embed Python in a permanent way, so you can take notes and you can write bits of code. You can copy bits of code into it, and one of the nice things is it's pretty interactive, and you have a permanent record of everything you've learned, everything you've typed, because you can save a notebook and come back to it another time. And that'll make a little more sense to you as we go along. And then we have VS Code. You know, as I said, you don't have to do any of this stuff. It's really likely that you already have Python installed on your machine. I don't know that, and if you don't know that, here's a way to find out. Here's a PowerShell window, and I've got some stuff running, so I'll just cancel out of it. And it looks like that one is dead, so we'll kill that. Now, one of the things you might wonder right off the bat is, will Python run on my machine? And the answer to that question is absolutely yes, it'll run on your machine. Python will run on a Mac, it'll run on a Linux system, it'll run on Windows. I happen to have a Windows system here. And it looks like I have another dead shell, so we'll just open up a brand new one. I've been experimenting with some machine learning stuff using a Python-based program called PyTorch lately. And I got some really complicated installations going on. Okay, come on. There we go. So if you just type in Python at a command prompt and you get something back, well, you've got Python on your machine. Just like that. Now, what you could be working on could include a Raspberry Pi. It could include a Sleepy Pi or a bunch of single board applications or any of the major platforms we talked about. Python will basically run on your toaster if it has a chip. But if you can get to a command prompt and type the word Python, and you have Python, what it'll do is it'll immediately come back and tell you what version of Python you have on your machine. It'll tell you a little bit more about it and where you got it and what version you have, but that'll be enough to establish you've got Python. If you don't have Python, no worries. We will install it when we do Anaconda. Okay, and I'm going to get out of Python just by saying exit. Pretty easy. It comes and it goes. Okay, let's assume you don't have Python, and let's assume you're working on a machine that you like to work on. First thing we're going to do here is get Anaconda going. So what you'll want to do is you'll want to go to anaconda.org. Okay, so just get a browser, type in anaconda.org, and you're going to get a page just like this one. And I'll give everybody a little bit of time to get to this point. Okay, now when you get there, one of the options is going to be download Anaconda. If you don't have Anaconda, that's just what you want to do. Okay, so you get Anaconda's download homepage here, and it'll give you a bunch of stuff about itself. It'll talk a little bit about packages. So Anaconda is fundamentally a package manager. And what that does is it takes care of all the accounting and bookkeeping for all the Python stuff that you put on your machine. Python is a language for sure, and it comes preloaded with all kinds of nice stuff. But it's got a lot of libraries that people have built that work with it. And they don't all install when you install Python. You have to put them on your machine 1 or 2 or 3 or 10 at a time. But you add them all on top. And they tend to be dependent upon one another. And what a package manager like Anaconda does is it makes sure that if you try to load an extra library onto your Python installation, that everything that library needs is also loaded, and that it all works and plays with all the other stuff you have loaded in your Python installation. Python comes with its own package manager, but it's harder to use. And when you start getting complicated stuff down the road, like data science-y stuff, it's really a pain in the butt to get that stuff going. And Anaconda makes that super easy. So you can read all about it at your convenience. But what you want to do to get it going is you want to come up here right near the top. And this web page is smart enough to figure out what kind of computer you have. All right. So if you click here on download, it'll automatically grok the kind of machine that you have. And as you can see, it'll run on anything. And just go ahead and download the package like so. Okay, and you can just agree to everything. Now, you don't have to give Anaconda any information about yourself. You can if you want to. It'll invite you at the end of the installation to download an Anaconda cheat sheet. You can do that or not. That's your call. But anyway, you want to install this like any other package and just say save. Okay, and I've already got it, but yours won't, but we can replace it. That'll just give me an idea about how long it's taking. So I'm using Firefox. So if I go to Tools and Download, I can keep an eye on it and figure out how long it's taking. Okay. So I'll give you guys a minute to let that happen. I've got pretty good bandwidth here. I know not everybody does. Okay, and when that's installed, you can go ahead and double click it like so. And I'm not going to reinstall it on mine, but if you get a message asking you to make it available to yourself or to everybody, you can do whatever you want to. I would recommend choosing all the default options though, including adding Anaconda to your path. Okay. So just go ahead and click next and get through it. You can agree to the license agreement. They're not terrible people, and Anaconda's site is pretty safe. I mean, nothing is really safe out there, but it's got a huge community, and the probability of having viruses and the such is pretty close to nil. Okay, so just agree to everything. You know, if you're the only one on your computer, you can install it for just me. That's fine. It simplifies it a little bit because it puts Anaconda in your home directory. If you put it in all users, it'll put it in a common directory. Okay, so then that's going to take a while. So yeah, I'm going to quit the installation. You guys keep installing. And while you're installing Anaconda, you can kind of keep an eye on it out of the corner of your eye. I'll talk a little bit more about Python and go back to the script for the lecture. Now, if anybody has questions while this is happening, just shout them out and it's completely okay. Okay, so what is Python? Python is a super easy computer language. As we'll learn, it was written mostly by a guy named Guido van Roosem. He's a Dutch guy. He was the architect of another simple language called ABC. And he got funding from the United States military through a program called DARPA, which is Advanced Projects Research. And it's a fund that that invests in world-changing technologies. It's a very long-sighted program, and it doesn't try for short-term hits necessarily, but it does fundamental research. So DARPA is the organization that funded the initial development of the internet, say. And they funded Guido because he had the possibility to make a computer program that was very, very easy to learn, very powerful, and very extensible. And the initial thinking is that it was going to increase scientific and technical literacy in the schools. So it's kind of pitched for kids. And it still is. You can teach this to kids. I've been teaching it to my Boy Scouts for years because it's sort of like, I don't know, like racquetball, if you've ever played with it. Racquetball, you can play it like 2 minutes after you pick up a racquetball racket for the first time. Like anybody can play it. But it's a deep enough game that you can play it for years and not really master it because there's always something more. Well, Python is like that. So you can write your first hello world program in about 10 seconds. But if you want to tackle deep learning applications or natural language processing, or you want to work with photographs, like with Photoshop, well, Python has a version of Python that'll do that. And there's literally thousands of things you can work with that are written in Python. Now, why does that work? Well, here's the trick. This is what a lot of people won't tell you. All Python is it's a wrapper. It's a means of accessing thousands and thousands and thousands, hundreds of thousands, millions of lines of C code. Okay, C code is written what they call close to the metal. It's written in something almost like machine language or assembly language, and it's powerful and it's efficient, but it's really hard to use. What Python does is it provides what they call an API or a means of accessing these complex libraries, all in the same way, all in what they call a Pythonic way. So with a Python wrapper over a piece of C code, you can talk to that piece of C code just like you're talking to anything in Python. And the next time you get something that is really a piece of C code, it's going to have the same interface. You can talk to it the same way. And then there's things written natively in Python. Of course, you can talk to those in the same way. So your knowledge of Python, what we're going to teach you here, is going to be sufficient to make efficient use of this monstrously large set of extremely valuable open source programs that are available to you and the world for free. Okay, so Python is a simple way to access a lot of different code, and it's a language to write other code. Okay, the programming language of the Agile era, I'm not so sure about that. There's lots of programming languages that work in the Agile era, but Python is a big one. And maybe Python, Java, and C++ will be the big languages, but Python is very popular. It's been the fastest growing language now for some years. Okay, and it's not going anywhere. It's got a huge community of people supporting it. Okay, this is a Python mascot, and Python is, all the open source languages have some kind of mascot, and a lot of them have really stupid names. Well, Python exists with this logo and by the name Python because Guido is a big fan of Monty Python. So you'll see zillions of lame Monty Python jokes sprinkled among the Python literature. And this is kind of the official logo. Here's a piece of trivia. The education minister for Python is one of my neighbors. He lives about 1 kilometer away, and he owns the official Python snake. It's a couple meters long. It's a stuffed snake about so big around, and he brings it to conferences all over the world. And here's another piece of trivia. Until just a couple years ago, the guy that ran the Python Software Foundation was another one of my neighbors. He lived even closer. And he's Steve Holden, known to my kids as Uncle Steve. So I live in this nest of Python people right here in Southeast Portland. Okay, so here's a more official, incorrect explanation for what is Python. It's an interpreted language. Okay, what interpreted means is that it gets executed on demand, line by line. There's no compilation step as there is with a language like C. So it just kind of runs in real time. And if you're using a code editor, or heck, even the command line, you can put in a line of code, and then you can interrogate the objects that you've created just in real time. It's very interactive that way. It's high level. And what high level means is you don't have to deal with pointers and stuff like that. Even things like iteration, where you're doing loops over objects, that's all handled under the hood. So if you want to loop over a collection of stuff, like your grocery list, you just say for thing in grocery list, print the thing. Okay, general purpose, that's pretty obvious. It does everything because it's such a general architecture, and that it can blend in elements from anywhere. Okay, this is who created it, Guido, and his thing was simplicity and readability. Okay. Now, one thing I'll show you right off the bat. Let me get my my interpreter back. See, of course, you can write down. I don't want that one. Of course, you can use a lot of different stuff for running Python, but you can get to it right from the command line. You say Python, then if you say import this, you'll see something called the Zen of Python. And this is the guiding philosophy behind the development of Python. This guy, Tim Peters, he's a good buddy of Guido's. And I won't belabor this right now, but just to give you a sense of what Python tries to be. It tries to be beautiful, because beautiful is better than ugly, right? It tries to be explicit. Say what you mean. You can say what you mean in code. Simple is better than complex, right? Very direct. Complex is better than complicated, right? Sparse is better than dense. Readability counts. So there's a whole bunch of stuff that is baked right into the language. And these are all careful design decisions made by Guido himself, where if there's ever a choice in development of the language, readability counts. He really believes in beautiful. So as far as possible, Python is beautiful and it is simple, okay? And it is sparse, it's parsimonious. That's all by design. Okay, I'm babbling a bit now, but it's the only language I've really come across that has these kinds of principles as part of its underlying philosophy. Okay, so these are the result of all this good planning. It's easy to teach it, learn it, use it, run it, develop it, and it's easy to contribute to. When your skills come up a little bit, Python is part of the world of open source. So not only is everybody in the world encouraged to download it and use it, but everybody in the world is also encouraged to make it better. So you can if there's some program, it could be Python, it could be anything else that you might pull into the Python ecosystem. If you think it can be done better, what the world will say to you is make it so, make it better. By all means, here's how you can contribute. Here's a list of stuff that we want to do. If you want to do something else, by all means, make a proposal for it or just do it and submit it. And if it works and you've got the right tests written, this will become part of that project. So you can really make the open source world your own. Okay, so let me stop talking here for a second. Does anybody not have Anaconda installed yet? Okay, so everybody's got Anaconda.
Sir, is PyCharm okay to use?
Say that again, please.
Can I use PyCharm instead, sir? I've downloaded PyCharm before.
Yeah, you can use PyCharm.
Okay, thank you.
Yeah, use anything you want to. You can use the command line if you want to. I'm just wanting you to know some of these other tools. Okay, then I'm going to assume that everybody has Anaconda installed. Okay.
I am attending the class without laptop computer. I am attending on an iPad.
Okay.
I'll just look your presentation.
Okay, fair enough. Yeah, we can do that. Okay, so the other thing I'd like everybody to install is something called VS Code. Now, this is completely optional. You don't have to, but VS Code it's a tool developed by Microsoft. Okay, and I'll just show you mine here. I think I got one open. Yeah. So it's a good and lightweight code editor. Here's what it looks like. Now there's a few nice things about it. It's free for one, but it's actually really nice. I mean, you never think that from Microsoft, but it gives you a file explorer where you can go look around your different files. It gives you a bunch of things you can add in. Okay, they're called extensions. So I happen to work with Docker a lot. I work with Angular a lot. I work with Python, and whatever you're working with, you can customize Visual Studio Code to support whatever you happen to be working with. And if it notices you're working with Python, it'll go and load up all the right extensions that you've asked for, and it'll apply those to the code you're working on. And it integrates really well with Docker, and it integrates really well with code repositories. If you don't know what those are, don't worry about it, but it'll automatically help you work with Git and GitHub. So it's a really cool application. You can get to it by going to code.visualstudio.com. Okay, and then that'll get you to one of Microsoft's sites. And it's pretty lightweight, so it's not going to take you a long time. But you can pick what system you're on. Okay. And if you just click on download, it'll be smart enough to get you to the right page, and you can just pick here. And it's going to be smart enough to grok what kind of Windows you have, or what kind of Linux you have, or what your Mac OS is. So you can just go ahead and download that and install it. All right. So back to the lecture. That can happen in background while we're talking a little bit more about Python. And here's a process point I should have brought up a little bit earlier. Today's lecture is going to be roughly 3 hours, or more precisely, it's going to be broken down into 3 45-minute sessions. In between the sessions, there's going to be a 15-minute break. So we'll pause and go on a break at quarter before the hour. So that's coming up in just about 10 minutes. And then we'll break for 15 minutes and come back at the top of the hour. Okay. And the other thing is if you're signed up for it, and I expect you are, you've got access to Slack, and there's a Slack channel here called Class Chat EN. All right, and I may share code in here if you have questions or things that you'd like an individual response to. Type them in here. I'll try to respond. I have to admit,
this channel is data science channel. We are using for our students here, Clarusway Tech Community. Slack channel.
Clarusway Tech Community. Oh, okay.
Yes, that's one.
Okay, terrific.
Okay, here you can use class chat as well.
Okay.
Thanks.
So I'm not seeing class chat. How about questions, answers, English? Does that work?
No, I can see class chat there.
Oh, yeah. Okay, I see that. All right.
Okay.
Thank you. Yeah, here we go. Okay, so here's the class chat. If you have questions, type them in there. I'll try to keep an eye on it. If I'm looking at something else, if I'm typing in code, I might not see it. So if that happens, just yell at me and I'll look at your question. Okay. Oh, Mehmet has installed Visual Studio Code. Yay. Okay, yay. So thanks for that feedback. We'll get rid of that here. Okay, so let's go back here. We'll keep talking a little bit in generalities, and then we'll jump into some code. So here is an example of some of the people that use Python. In fact, my friend, the Minister of Education for Python, he worked on a project for NASA for the Jet Propulsion Laboratory. That's in California, and they're the ones that run the Hubble telescope, the space telescope. And they were in the process, this is about 3 or 4 years ago, of switching from proprietary software to Python, because the Hubble is kind of at the end of its life, and funding was getting really sketchy, and nobody expected the Hubble to last as long as it has, but it's up there and it's doing beautiful work, and they decided to keep it, but they didn't have any budget, so they switched from their proprietary software, and they're using it mostly for data storage and for visual processing, which, is you can imagine, is huge. And he taught NASA what they needed to know in order to do that. NSA, that's the United States Spy Agency. Nobody really knows what they do, but I've got some friends working there, mostly on matters related to cryptology. But it's used by some really big companies, and they're not all using it because it's cheap. They're using it because it's good, and they're using it because the learning curve is so short. And there's so much infrastructure built there. So if you want to develop a program, to do cryptography or anything else, and you're starting from scratch and you're writing C code, it could be years before you have anything that works. If you're working with Python, you can probably find something that already exists that almost works for what you need. And it's all open source, so it's pretty easy to change it. And Python is what they call an object-oriented language. So it does inheritance. So if you write like a class in Python that does something really well, and then you want it to do something different without mucking around with the class, you can inherit everything from it and then change little bits of it without breaking anything. Or you can break your own stuff, but you can do that without mucking around with the original. Okay, so it does inheritance, and you can it's very modular, right? So you can do multiple inheritance, and you can really work with it. Okay. So here's a Python brochure you can look at if you want to. We're not going to go through it in this class, but you can have a look at it. But the Python world is so big, you can type in any Python question you want to, and Google will come up with 1,000 hits on it. Okay. Now here's the guy that developed Python, Guido van Rossum. And when we come back from break, I'll show you this really short video. But as I said before, he's a Dutch guy he's one of the few people on earth with a job description of software architect. And he's just always done it. And he loves it. And when he finished a project called ABC, and he got a little bit of money from DARPA, he gathered a small team and just started doing Python. And he was until like maybe a year ago, the benevolent dictator for life, BDFL. And it's actually a software governance thing. A lot of software projects, like a corporation might have a CEO and a chief operating officer and a chief financial operator, and it's very pyramidal. Well, Guido is the dictator, or was. So essentially every aspect of Python had to have his approval, which sounds pretty undemocratic, and it is. But for a software project, that kind of works because it's Guido that maintained the quality assurance for this thing, soup to nuts, everything, from its inception to what we see today. Now some other bright people have taken over, and it's taken a slight turn. There's stuff in the newest version 10, that Guido doesn't really approve of and never did. But let's see. Oh, okay. Yeah. Yeah, so some stuff in Python now that Guido hadn't really approved of and never did, like there's a case statement like thing in there now, but it pretty much maintains his imprint. Okay, Tugba, thank you for doing this. Tugba reminds us, if you can't download anything right now, and you want to play around with notebooks, you can go to Google Colab. All right. So it's colab.research.google.com. And that basically provides you a free Google notebook or a free Jupyter notebook. It's got Python installed. No such agency. That's the NSA. Thanks, Mama. Okay. So if you want to, if you're working on your tablet or something like that, and you want to do a little coding today, by all means, have a look at this. So I want you to jot that down now if you want to do it, and maybe you can get on it over break. Because when we go on break, which we'll do in about a minute, this screen is going to go away. Okay, and you won't be able to see it. You'll see that really happy girl in front of the computer doing this. Okay, so it's break time. We'll see you guys back at the top of the hour. And at the top of the hour, we'll hear from Guido, and we'll start typing a little code, and you can then feel as though you actually walked out of here writing your first Python script. Okay, so I'll see you at the top of the hour. Enjoy your coffee, and I'll be tanking up myself, and I'll be drinking my first couple of sips to your honor. See you later.
See you, Pat.
I hope everybody had a good break. So we're going to pick up where we left off. We talked a little bit about a couple of the tools available that you can download, Anaconda and VS Code, and a little bit generally about what Python is about. We're about to hear from the benevolent dictator for life, Guido. But before we do that, I just this is just totally random, but I've been working on something else on my own. I'm learning a program called PyTorch, and it just so happens that an ad popped up, which I will show you real quick. Okay, there is an annual Python conference that happens. There's a PyCon US for those of you in North America. There's also a PyCon EU. There used to be a PyCon Turkey. But anyway, Python has a huge community of people that support annual conferences. This particular one is an ad to see if I want to do a paper, and I might, because if you do a paper, usually you get in for free. But I'm sharing this with you because if you stay interested in Python, these conferences are a great resource. And a couple of things you might be interested in is if you're a student, they usually offer scholarships, so you don't even have to pay. They usually will include like an Airbnb-like message board where you can find somebody in the local Python community to couch surf on. See, you sometimes don't have to pay for a hotel. And if you're a lady, there is a group called Py Ladies, and it's a group funded and supported by the Python community to try to encourage ladies to get into programming, and particularly Python. And they've got their own funding for things like scholarship and travel and stuff like that. So it's worth finding out. You can get a hold of community resources that are pretty lavish, really, to help people that are just coming into the field. But anyway, back to the lecture. So this is Guido. We'll see now about a 4-minute talk by Guido, just his introduction to his child. So let's play it. Okay, I guess we'll skip this. What I'll do is I'll post the Guido's talk into the chat. Sorry about that. Okay, sorry about that. Anyway, it's worthwhile hearing his spiel, and he just basically talks a little bit about how he got into Python and why and where it's going. Okay, so let's talk a little bit about some of the tools that we mentioned earlier, and I hope you've got them installed. But if you don't, you might get a couple of tips here. There are some tools out there, including Google Colab, and thanks a lot for telling us about that. Who was it? It was Tugba. Sorry. So there's a bunch of online tools that host Jupyter notebooks that are available if you just have a browser. And if you just Google the words hosted Jupyter notebooks, you'll find a whole bunch. Okay, so there's one called Python Playground, and it lets you type in Python code and get an output. So this is basically just a simple online implementation of a Jupyter notebook. Okay, you can download Python directly. And this used to be right, but the current version is now version 3.10. Okay, and you can get all the versions of Python available directly from Python. If you work with the Python distributions, you can use the Python package manager. It's called pip. And you can use that from the command line. Or you can use Anaconda. So there's a program called pip. Okay, and this is gonna just tell the different commands. If you use the command pip from your command line, which you can do when you've installed Python from wherever you've gotten Python, you can do things like pip install to install different packages. And you can uninstall packages using pip uninstall. There's other ways to install packages, but if you use pip install or conda install, also available from the command line, and uninstall, then you can manage your packages and your package dependencies really easily. If you start doing stuff manually, like if you find some package you want and you install it manually, you're asking for it to not work, and you'll learn a lot. You'll get to have opportunities to discover things like package dependencies on your own, but it might be a whole lot more trouble than you want to go through. So you generally use conda install or pip install if you're adding packages. So you use pip with Python and conda if you've installed Anaconda and you intend to use that. Okay, but here's Python's official site. You can get the latest version or any other version. The installation process is really straightforward. Okay. One thing I would mention here is Python has a lot of versions, right? So this is version 3, that's a major release. And then 3.9 would be like a specific release. And they get further versionated as you get out here into .5 or .3 or whatever. And by the time you get into the dots, you're talking experimental versions. Okay, and the other thing I would say is old versions of Python, Python 2.7 is a real popular version because that was a stable version for many years. And a lot of code is written against Python 2.7. It's kind of a complicated topic, but what you want to know for now is Python 2 is a very different language than Python 3. And if you write in Python 2.7, it won't work in 3. probably. And if you write in Python 3, it probably won't work in 2. What version of Python you have, as long as you have Python 3 point something, you'll do fine. So don't sweat, you know, whether you got 3.9.5 or 3.10 or 3.8, because they're all pretty much interoperable. Okay. When you install it, it's really straightforward. Typically, you'll want to, whether you're installing Python straight up or Anaconda, you'll want to add Python to your path. And what path is, it's an environment variable. And it's just a list of different places the operating system is supposed to go look if you ask to run something. So I've got, when I had my command window up, I typed Python, but I didn't have to be in that directory, whatever directory I had Python in, because that's one of the list of places I've asked my operating system to go look. So you'll want to check this box. Or if it doesn't work when you type it from the command line, you'll want to figure out why, and why is always going to have something to do with your environment variables. Other than that, it's like really super straightforward. VS Code, you guys downloaded that. Okay. What you want to know about VS Code is you want to have an extension loaded to help you with Python. And I'll show you real quick again what that looks like. Okay, so here's my VS Code. And I've been playing around with some PyTorch stuff. But if you go into this thing with a bunch of boxes in it, those are the extensions. And if you just type in the word Python, it'll go and find all the extensions that it knows about that'll help you. And there's quite a few of them. You can explore those. Some people swear by them. Some people think they're distracting. It's up to you. But this one here, the main Python one that pops up at the top, you want that because it has IntelliSense. And what IntelliSense is if you type in a little bit of code, it'll guess what you mean, and it'll fill in the rest of it. So some of the APIs, some of the interfaces to the objects can be a little bit complicated, but it'll not only try to guess what you're trying to type, but it'll give you prompts and hints as to what the syntax is. So it keeps you from having to remember a whole bunch of stuff. Okay, so you want to install this. It takes just a few seconds. And at that point, as soon as you type, you create a new file. And if you save it as something, and here we'll just call it something.py. Okay, as soon as you put a .py extension on a file, what you're going to do is signal to the world, the operating system, your colleagues, everybody, that you have a Python file. You always want to have a .py extension. But as soon as you do that, when you start typing something like this, oh, you know what? I have okay. I have my okay. I'm a big Vim guy. Okay, and I have my Vim things on here. So if I'm going to say print, okay, this is not working here. Okay, I don't know why it's not working. Anyway, trust me, this will help you fill in blanks as you're working. And let's see, I have Python live share. Okay, and I've got my extensions on. Anyway, I'm not able to get that. Oh, here we go. So let's say print. Okay, so it's going to do spacing for us. And it'll do it'll fill in, like if we have a paren, it'll automatically fill in the closing paren. It'll do all kinds of stuff like that for you. You can use it or not, totally your call, but I recommend it. Okay. And here's where they show it in the handouts. Okay. Anaconda, we've talked a little bit about that. Okay, you can install it. There's a whole bunch of different flavors. Here's where you can install Python 2.7 if you need that. One of the things I didn't mention, and it's really good to know, is that Anaconda supports what's called virtual environments. What's a virtual environment? Well, it's a way to create isolated instances of Python on your computer. So you might install Python 3.8 because Python or Anaconda wanted to install that, and that's completely cool. If you wanted to install version 3.10.1, some experimental version of Python, you don't want it to conflict with Python 3.8. And if you install Python 2.7 for whatever reason, you don't want it to conflict. Anyway, virtual environments give you the ability to segregate Python and all the packages you install for each version, so they can't possibly get in each other's way. You can learn a lot. It's beyond the scope of this class, but you can learn a lot more about it by just typing in Anaconda virtual environments, or type in Anaconda cheat sheet, and you'll get instructions for preparing a virtual environment for yourself. But Anaconda does that out of the box. You can do that if you're just using straight up Python easily enough, using a package called virtual env. But that's kind of beyond the scope of this class too. I'm just telling you they're out there. So do use virtual environments. Okay. So Jupyter Notebook is the notebooks I'll be showing you. Visual Studio Code. We just looked at that. I won't be using that so much, but know that it's there. And no matter where you get Python, as you've seen, you can always run it from the command line or use PyCharm. And finally, I would mention that Python comes with its own IDE, integrated development environment, called Idle, named after Eric Idle, of course, of Monty Python fame. But it comes with a lightweight code editor that's got some smarts to it, if you want to work with that. But I like Jupyter Notebook a lot. Okay, any questions so far? Okay, so let's write some code. I'm going to come here to my PowerShell, and I'm going to get rid of this stuff. And I'm going to invoke a Jupyter Notebook. Now I can see that parenthetically over here, we have base. Okay. And this is the virtual environment we're working in. This is what Anaconda provides right out of the box. I've got other virtual environments, but I'm not going to invoke them right now. I'll just go with that. And I'll say Jupyter. It's spelled with a PY. And that's a tip of the hat to the fact that the tradition of Jupyter Notebooks came from IPython or IronPython. But it now supports R and let's see, Julia, and about a dozen other languages. But it's really easy to invoke. You say Jupyter Notebook. That's it. And when I hit return, it's going to create a web page, and it's going to create a server. And that server is going to serve that web page. Okay. And it'll give me a bunch of stuff here. And it'll tell me how I can access the notebook that we just created. All right. And when we're done with it, we can hit Control-C and it'll kill it. By default, it's going to start up the server on port 8888 on our local machine. Okay. This is very much of a client server environment. You can use a web browser as a client against Jupyter Notebook running anywhere on Earth. It doesn't have to be on your local machine. You just have to browse to the right URL and you can get to it. So I'll just copy this token thing, all this gibberish back here. That's just a security thing. And that makes sure you can't do cross-script referencing, which is a fancy way of saying you can't accidentally be working with a notebook and then have a bunch of stuff run on your machine unless you've managed to get this token somehow, which if you look at it, it's about impossible to do that. So I've just copied one of these URLs, and what's happened is it's made this server, and as we play with our notebook, we can keep our eye on what the server is doing here. And usually you don't need to know anything about it. Yeah.
Sorry, I was just wondering how did you start with the base in a PowerShell?
Because that's the base installation of Anaconda. If you, well, maybe you didn't see base. I'll hit a Control-C to get out of here. Okay, so if you don't see that, you can say Conda activate base. And that'll give you your Conda environment. I happen to have a bunch of different Python virtual environments on my machine. So if I wanted to activate 3.9, I would get that instead. So I can change.
So I tried to Conda. I did try to Conda activate base, but it looks like I am not getting anywhere with this. It's just the term Conda is not recognized. Does that mean I haven't installed anything or something that I need to?
That probably means that wherever Conda installed on your machine, it's not part of your path environment variable. What kind of machine do you have?
I'm actually using virtual machine, like the virtual instances. Like, does that affect?
You mean like a VirtualBox or VMware virtual machine?
Yes. Yeah, like Amazon Workspaces.
Oh, okay. What operating system is it?
It's a Windows 10.
Okay. What you want to do is you want to figure out where Anaconda is. So on my particular machine, let's see, I've got it installed in my root directory here. So I've got C Anaconda 3. So what you want to do is you want to make sure that that is part of your path. And you can get to that by coming here and let's see, it's going to be a setting. Oh, you know what I'm going to do? I'm just going to search for it here. Okay, and I have 3 screens, so this stuff is all over the place. So let me pull it into something that you can see. Okay, I'm going to kill that. I'm going to come here. Okay, so I'm going to search for environment variables. So I'm going to come here. I'm going to edit the system environment variables. All right, and I'm going to come here in environment variables. Okay, and here I have my system variables and I have my local variables. Okay, so
Yep.
you want to put you want to make sure that the location of the conda, right, is in your path, and you can do that by
Okay,
editing the path. Got it?
There.
Okay.
Okay, I think I don't see any of the Anaconda files in it. I thought I downloaded it, but it seems like it's just the Anaconda Navigator. Do I have to specifically download something?
Well, you want to download it, and then let's cancel out of here. You want to download it and then install it, and you should be able to do that even
Yes.
on. Yeah,
Alright.
and that's going to install by default in your root directory, C Anaconda, if you've installed it for all users, or it's going to install it in your user directory if you've just installed it for yourself.
Gotcha.
In either case, you either want to you want to reference that directory in your command line. So you'll want to do something like C colon Anaconda, and then conda. That should work to get there, or navigate to it in your command window.
Gotcha. I'll figure something out. It seems like it's not been installed on my my computer for some reason.
Okay, well, just you might just want to go to your whatever browser you have and go to Tools, Downloads, and run it again.
Okay, we'll do that.
Okay,
Thank you, sir.
sure. And if you can't figure it out by the end of class, we can stay on a chat or something, and we'll get it worked out.
I also have the same problem.
Okay.
Yeah, no problem.
I did
Same here.
everything that you said to do, and it still is giving me an error message. And yeah, I don't know what to do now.
All
Yeah.
right. What's the error message?
Let me pull it up again. It says, conda, the term conda is not recognized as the name of the CMDLET function, script file, or operable program. Check the spelling of the name, or if the path was included. Verify that the path is correct and try again. And then
Okay.
there's more stuff.
Okay, so it's the same issue for everybody here. So what you want to do is you want to get to a Finder window or Explorer window, File Explorer window, depending on what kind of system you have. Okay, and you want to find out where Anaconda lives. Okay, and it's probably going to be at the root of your root directory, or it's going to be at the root of your user directory. Okay, so it's going to be C users, and on my machine I'm Pat. So it's going to be on my machine C users Pat, or it's going to be C Anaconda. So see if you can't find it. Okay, and once you found it, then put it on your path. I'm gonna give you a couple minutes to do that. And if you're on a Linux system, you can add your path on the command line if you're good at the command line, or there's going to be a GUI if you use Ubuntu or something to edit your path. On a Windows system, you can just search for environment variables. So. And if we can't collectively get it figured out in a few minutes, we'll work with the command line, and what I'll do in the meantime is try to get a consolidated, detailed set of instructions together for you and have it shipped out.
Excuse me, Pat. Once we actually open the Anaconda, I guess, PowerShell prompt, and we can see the base, what did you use to, I guess, test it out? What was that path that you typed in once you?
Well, to get it going, all you got to do, if it's on your path, if your operating system can find it, you say Jupyter Notebook. So. And it'll think about it for a bit, and then it'll give you a bunch of information about what it's doing. And particularly, it'll tell you what URL to go to. And what it'll do at the same time is it will open up a browser window, or add another tab to an existing browser window. And it'll give you the ability to interact with it. Okay, but so many people are having issues.
I see what you mean, though, Pat. I actually just got it to work for me, and it went to the site. So thank you.
Awesome. Okay. So maybe we won't use a notebook right now, because everything we're going to do for this class we can do from a command line, and working on a command line is it's good to know how to do anyway. So what I'll do is I'll get another shell like so. And it doesn't matter. Use whatever shell you like. It really doesn't matter. But getting Python going is really, really, really easy. And I've kind of showed you before. You just type the word Python like so. Okay, and when you type in the word Python, of course, you're going to invoke, let's get rid of this thing. You're going to invoke the Python interpreter. You know you're talking to the Python interpreter because you have this, this weird hashy thing. You might call it a chevron. Okay, that's a Python command prompt. Okay, now Python is an interpreted language, right? So it's just got a catcher's mitt out there and it says, give me a line, give me a line. I want to do something with a line. So you're talking right to it, and you don't really need any intercessions. So let's write a first script. Python has with it a method called print. All right. Now, if you just type the word print, well, the interpreter, it's listening for you. Well, it'll tell you what it is. it tells you it's a built-in function print. So there's actually a couple pieces of information baked into this. It tells you it's built in, so it's part of the main Python language. It tells you it's a function, so it's executable. Okay, and it tells you back its name. Okay. Now, if we want to use it, what we want to do is, since it's a function, we'll use an operator. And the opposing parentheses is an operator. That means execute me. Now, if you do this, not much will happen. But you've actually executed that function. See, you can tell because it left a blank line. That's not terribly interesting, is it? Let's ask it to print something. So what we'll ask it to print is a string. So what is a string? A string is any number of characters surrounded by quotes. So like Quinn the husky, that's my dog, is a string. Okay, and if we just type it in, it'll reflect back to us what we typed in. If we ask Python to print in the husky, like so, we use open and close parens. We're saying, hey, print, we want you to execute. And we're putting something in between the parentheses. It's called an argument. All right, so we're saying print Quinn the husky. And if we hit return, lo and behold, it printed Quinn the husky. Now, I just broke every rule in the book. You know what? Because the software police are going to come haul me away. Because really the first program you're supposed to write is hello world. So we can do this. The print statement is pretty versatile. So we can put a quote and the word hello, and then the word world. Now we've got to enclose it in quotes, like so. And it will print hello world. With me so far? Now, one of the things I'll point out as we're going is we're using, I'll make a comment here, and you make a comment with a pound sign. What we're using is something called a REPL. And that stands for read, execute, print loop. And that's what makes Python so interactive, because when we're talking to the interpreter, as we're doing right now, under the hood, there's a little guy who's constantly listening for stuff we're typing. And every time we type something, it'll read it and then execute it. And if there's anything to print, it'll print it. And then it'll come back with a prompt telling us it's ready for more stuff. Now, because we have a pound sign here, it's going to ignore this line of code. It's not really code, it's just a comment, and it'll come back with a prompt because we haven't really asked to do anything. All right. So this is a string, hello world. Now, I'm going to use this opportunity to introduce you to the most important aspect of Python. And it's not in your handouts, but I'm going to introduce it to you anyway, because we have created an object right here. We've created an object, Quinn the husky, which is a string. We've created another object, hello world, which is a string. Okay. And here we've performed an operation using that string as an argument. Okay. Now, because we have an object, it's a string, we can call that string a message. We can provide a name for it. And to provide a name for it, we use the assignment operator, an equal sign. So we've created an arbitrary name. It's called message. And we're going to give it a string. Let's call it Quinn. Right. Now, when we hit return, you won't see a lot coming back. It didn't give us an error, so it acknowledged that, silently that it accepted this line of code. But now, if we type in the word message and we spell it correctly, then we'll invoke the REPL, the read, execute, and print loop, and it will say something about itself. And what it says about itself by default is it echoes the contents. It echoes the object associated with the name. So it's echoed the object Quinn the Husky. All right, now we can learn a lot about Quinn the Husky. Now we can just refer to this string. We can keep typing it all the time, but we don't have to. We've given it a name called MSG. So if we want to learn about our message, we can say help and give it the name of the thing that we want to know about. And this help, this 4-letter word, is the most important part of Python, because using this simple command, you can learn all of Python. Using the simple command, you can learn about any object that you've created. Okay, now this is going to yell at us. It says we can't find documentation for this specific object, but it's a string. So type instead help and then string. So this object is a string. We can type in string and it'll tell us that it's a built-in object, right? It's a class. If we say help string, we will get, and be prepared, a ton of information. So all of Python objects come with built-in documentation on that object. This is way too much to read and go over. In fact, there's so much it doesn't even fit on a page. So I'm going to hit return. And if you're used to working with Vim, you can shortcut this. But you can hit return until it's done printing out all this information about this object we just created. Pretty cool. We didn't have to crack open a manual. We didn't have to go Google anything. This is right here in our terminal. And look at all this stuff we can learn about. And I won't bore you with all of it, but I'll do a little bit to help you decode it. And we're going to take a break in about a minute, and I can show you a little bit more. But here it tells us what it is. It tells us how to use it. So we can use it as a verb, and we can convert some object to a string. Okay. In this sense, it will create a new string object. There's all kinds of methods, and methods are a fancy computer word for verbs. These are things that it knows how to do. And a lot of them have funny names. We don't have to know about those right now. But when we get down to the stuff that doesn't start with the underscores, it shows us everything we can do with this string. Like we can capitalize it, we can count it, we can encode it, we can figure out if it begins or ends with something. Okay, so we've got a lot of complexity in here, but you don't have to worry about it. It's all right there. And when you're ready to learn about it, you can learn about it with a single command. So anyway, that's help, and that's the most important thing. And if you forget everything except how to use this, you'll still get good at Python. But anyway, it's time for a break. So we'll stop now for 15 minutes and come back at the top of the hour. Okay, and if you get back a little bit early, you might see if you can try to install Jupyter Notebook and figure out how to fix your path to get there. And if you have questions, you can type them into the chat, and I'll try to answer them. I'll get back a little bit early so I can do that. Okay, so I'll see y'all in about 15 minutes. Okay, guys, we're back. Hope everybody had a good few minutes without listening to me yap at them. Okay, so we left talking about strings, and possibly more importantly, we learned how to get help on string objects, and by extension, we learned how to get help on any kind of an object that Python has. Now, don't be intimidated by all this stuff, because you don't need it all right now. You don't even want it now right now. But bear in mind that that this help facility is actually pretty flexible. Let's just say, and I know you're not, but let's say you're interested in this one, title. So print has within it something called title. We don't know what it is. It just says that it has something called title. So we can modify our help and say help string dot title. And it'll give us more of a silver bullet. So it'll tell us exactly a little bit of help on this particular thing. So this will return a version of the string where each word is title cased. Okay. And there might be another one, I know there is, called string.lower. And that's one of the things that went by in that blizzard of stuff. And it'll tell us it's a method. Okay. And it returns a copy of the string converted to lowercase, and it shows us how to use it. So if we looked at our message, Quinn the Husky, well, we can say message.lower, and it'll convert that to a lowercase string. Now we could learn that, and we could learn about title or anything just by asking it. So if we wanted to say message.title, it'll give us a title case version of it. So you capitalize the T. Okay, so you've got access to a whole bunch of stuff simply by using the word help. So let's clear off our screen a little bit. In fact, what I'm going to do is I'm going to exit Python for a second. And we'll clear the screen, and we'll invoke Python again. I think you'll be able to see it a little bit better. So we saw that we could create a string by using a single quote. And we'll just call it Quinn for now. And that creates an object which will echo back. We can assign a name to it. Like so, and have access to the object, the string, by its name. Okay, cool. Now, this is only one way to make a string. Okay. And if we say the word make, we're basically saying it's a constructor. Okay, that's a computer term for making something. So with strings, there's a few different constructors. So you can make a string using single quotes, as we've seen. We can also make a string using double quotes. like so. See, we're enclosing our string in the same kind of quote. Okay, we can also do triplets of them. Okay, so here we've got a triplet of single quotes. And similarly, we can use double quotes. Spell it right. So any of these 4 different methods or techniques are a way to make a string. So if we wanted to say Quinn, like so, that is completely legitimate. It'll echo back Quinn. Now notice it doesn't echo back the double quotes, right? It echoes back single quotes. Okay. And that's how Python signals that it's thinking about a string. It's enclosed in single quotes, no matter how you construct it. So that's a visual indication of the type of object that you've created. If we wanted to ask it what type it is, we can use the word type, and it'll tell us we have a string object. If we wanted to use single quotes, it'll tell us we've got a string object. Okay, so it doesn't care. It's just a string. Okay, so why, you might wonder, why would we want to have different ways to make a string? Well, here's a simple use case. If we wanted to say Quinn's bone, like so, we could do that. Now, notice inside here we have a single quote. But since we were enclosing the whole string in double quotes, we can get away with that, because Python knows that everything between the double quotes is what we intend to be the contents of the string. All right, so it's happy. Okay. If we wanted to enclose a double quote, we can do that by making the outside of it single quotes. So, and it'll be completely happy. There's other ways to get around this problem, but the simplest one is to just pick the quote marks on the outside the way you like them. Now, a lot of people advocate for the use of single quotes just because they're simple and they're easy on the eyes, but you can do it any way you want to. Right. Now, we've also had the possibility to do triplets of single quotes and triplets of double quotes. So why do we have yet another way to make strings? Well, the answer is simple. Because if you have triples, that lets you make a multi-line quote. So if we wanted to put triple quotes in here, we could say something like, now is the time. And then we can continue this line. And look how the prompt changed. When we have these 3 chevron things, we're talking to the Python interpreter, but when it shows us 3 dots, it's waiting for more input, because the interpreter is smart enough to know that we're not done with our line. It's waiting for these closing 3 quotes. So this is telling us, hey, I am here, but I'm waiting. You're not finished, dude. So we can finish the quote. For all good dogs to go on a walk. Okay, now as soon as we close this off with triple quotes, it'll know we're finished. And it echoed back exactly what we typed in those 3 lines. Exactly? Maybe not. What's this funny character? Well, this is actually one character, and that signals a new line. This one too. Okay, so the interpreter interpreted the fact that I hit a carriage return after the word time, and after dogs. It interpreted that to mean that I really meant it. And its version of a new line character is a /n. You can think of that as a single character, like so. With /n is one character. So it took very literally what I put in, and it came up with its own way to report that, and embed that within our string. Okay, now it works the same as for double quotes, and let's name this. Let's make a double quoted, a double quoted triple, and we'll give it a name. So we can say, I don't know, words. We can assign the name words to a triple quoted string. And let's just say something like the climate change meeting in Scotland could be huge. Okay, so now we've assigned a multi-line string using double quotes to a name. And if we wanted to use the REPL to report words, we could just type in words, and it'll give us our string back. Okay, and you'll note again that it embedded these new line characters. Now, why do you think it would embed new line characters? Well, the reason is that if we printed words, well, the print method is a way to process strings. We have a string in a way that is going to be meaningful to humans when it's reported out as text. And watch what happens. Okay, so the print function honored these new line characters. Okay, and it used those as it processed this string that we created to make a printable version of it. Okay, so these things, you'll see them from time to time. I won't belabor right now, but you'll see funny characters like a / and a T, and that means a tab character. All right, and you might see an N, or you might see an R, and these are like new lines or carriage returns. Okay, and these are text versions of it. If you sometimes you'll see something like this. Okay, and that means the first one of these is called the escape character. Okay, and the second is what prints. Okay, so the / here is an escape character, and all that really means is what follows it has a special meaning. Okay, so these two are going to signal a new line or a carriage return. This T is going to signal a tab. And if we just put a /, we're saying, hey, don't worry about it. We really mean a /. So that way, if we wanted to say print, and print is a function, so we'll want to execute it. So we'll put it between parens. And we might say, hey, a tab. And we can say T. And then we can say, hey, a new line. And we can say N. And we can continue here. Right. And now it yelled at me. One of the other nice things about Python is when you screw it up, it'll yell at you. Now, this is an exception in Python. Okay, it's an error, and it'll do its level best to tell you what it had a problem with. And this is saying the end of the line was encountered while scanning the string literal. Basically, it's saying, dude, I don't know what the end of the line is. And it's right, because I didn't put a closing quote in here. And it's even telling me about where it had a problem. So I'll correct that. So if you're working on a command line, you can use the up arrow and you can recall all the lines that you've typed. It'll go through all the history. So I'm hitting the down arrow now, so I'm scrolling up and down through the history. All right. So I'm back to my last line, so I can just edit that line by putting in a quote. And here we see that it honored these tab characters. Okay, and then it honored our new line character. And then it finished up our string on the next line. Okay, so you've got 4 ways to make a string, right? You can go with single quotes. You can go with double quotes. You can, if you want to, make a multiple line or multiple lines in the same string. And you can do that with the triplets, and you can do that with either kind of triplet. Okay. Questions on that? Now, if you have multi-line strings like this, Python will interpret new line characters, and it'll remember them as /n. And if you're using the REPL, just by typing the word words, it's going to include these special characters in the string. And if you print it, it's going to honor those and come up with something human readable that'll take care of the new line of the tab. Okay, so that's your first object. Now, most importantly, you know how to get help on it, right? So you can just say help in any object at all. You can even say help on help, by the way. And it'll tell you all about how to use help. It's pretty cool. All right. Now, I recommend using single quotes because they're easy to read. There's no requirement. Your team, when you get out there in the world and have a job, that they might well have their own convention on how to use it. You'll want to honor that. Okay. So it just doesn't matter. Now, let's talk a little bit about style, because you'll remember from the Zen of Python that beautiful is better than ugly and explicit is better than implicit. Python has a bunch of style that is used by convention, and it's got a bunch of style that's used by fiat. It's enforced. So for instance, and we'll get into this a little bit later in the class, if you wanted to look at our message, Quinn, and we wanted to iterate through that message, we could ask Python to go through and say, well, okay, the first character is a Q, the second is a U, the third is an I, and then there's two N's. It'll go through one character at a time. So if you wanted to say for character in message, that's a real simple way to iterate through something. Well, Python is going to require that you provide indentation, like so. And you can print out each of the individual characters one at a time, like so. So Python enforces some style in terms of indentation. It has a bunch of conventions that will suggest strongly how it is you code Python. And some of those conventions are to use lowercase names for ordinary variables. So message is a pretty good example of an ordinary variable name. If you wanted to create a long message, you want to use lowercase and you put an underscore between words. You can use these triples if you want to on a single line. Python's completely happy with that. All right, and you can learn a lot. It's kind of beyond the scope of the class to go through all this stuff, but you can learn a lot about Python's styling by looking for something called PEP8. All right, and if you just Google PEP8, you'll come right up. And you will learn about how it is that you're supposed to style Python. And I'm going to show this to you real quick and talk a little bit about what these PEPs are. This is part of Python. This is a Python enhancement proposal. And in terms of how Python developed, Guido had the basic idea for how to make Python his dream language. And one of the conventions that he imposed is if you've got an idea for how Python could be better, write it up in terms of a proposal. And they're numbered. The first one, of course, was PEP1 and then PEP2. Well, PEP8 is obviously very, very early on in Python's development, right? Explicit is better than implicit. Simple is better than complex. What does that mean? What did it mean to Guido? And you'll see in this Google search came up, and PEP20 was incorporating the Zen of Python into Python itself. Okay. Now, one thing I'll point out about this is this was written in 2001. Okay, that's the year Python was introduced. Who wrote it? None other than Guido himself. Okay, so this is a real foundational bit of Python. It's a combination of lore and stern instruction. It's a little bit of a dry read, I think, and you'll see there's Monty Python references everywhere. But it shows you like how long a line ought to be, how you use indentation, where to put blank lines, how to format stuff. And Guido has a little soapbox here he stands on and yells at people. Anyway, it's worth knowing this. And it's also worth knowing that the standards in this document are they're actually encoded, and there are programs you can get that will enforce PEP 8 standards onto your Python code. So somebody said she was using PyCharm. That's a commercial Python editor, or editor of many languages, really. But it's aimed at Python, and it will correct your code to do the right kind of indentations and suggest the right kind of variable names and that kind of thing as you're typing if you wanted to. And if you use Jupyter Notebooks, there's an extension you can install where you can push a button and it'll correct your code into PEP 8 stylings. So just I thought you'd want to know. So just, you don't have to remember all this stuff now, but just remember PEP 8 and try to write your code per those standards. And it'll give you all kinds of advice, like make your variable names meaningful. Don't make people guess. If you're writing classes and functions and methods, and those are all part of object-oriented programming, they have their own casing conventions. Ordinary variables are all lowercase, classes begin with a capital letter, and so on. You don't have to remember it all right now, but just know that stuff exists. All right. Any questions? Okay, so let's review some of this stuff. And I'm gonna shift from a command line into a Jupyter Notebook. And I know not everybody has that installed yet, but hopefully this will inspire you to work out the path issues that you might be experiencing. So I'm going to come back here. So I want you to know how to work with this. And I hope you'll see quickly that although we can work with Python on a command line or any kind of a code editor, Notebook has a lot of advantages if you're learning stuff. All right, so when I typed in Jupyter Notebook here, it gave me a bunch of information about what the heck it's doing under the hood. And it told us the URL to use to get it. And it went ahead and opened it up for us. And what it opened up to was this homepage. Now the homepage, it reflects the contents of whatever directory we're in when the Python Notebook command was invoked. And you can see here we got a lot of stuff. And it's kind of too much for my liking right now. So what I'm going to do is I'm going to get back to where we invoked the notebook, and I'm going to kill it with a Control-C as instructed up here. This will stop the notebook server. And we'll get a few lines telling us that it's shut down. And we're in my home directory right now. So I'm going to make a new directory, and I'm going to call it junk, just because I'm not going to have anything that interesting here. Now, actually, let's make it demo notebook. Okay, and then I'll change into that directory. And if we look at our notebook, we can see it's, or our directory, we can see that it's empty. And here we'll do a Jupyter Notebook. And we'll get something a lot cleaner to look at. In fact, it'll be an empty directory. Okay, so we'll see we've got some options configured, and it's going to open a new tree, and it's going to point to our empty directory. All right, now if any of you have done any web programming before, you'll recognize the fact that we started our server in some directory, and this is the web root of this server. All right. Now, under the hood and behind the scenes, there is a version of Python. And if we come over here to new, I happen to have a whole bunch of Pythons installed, but you'll definitely have a Python 3. And you can pick which kernel. You'll only have one. And we're going to pick a new notebook using the only kernel available to us. And you'll see over here behind, we're getting a lot of information. This is log information from our Jupyter Notebook server. Okay, usually you don't have to pay attention to that. This is just some extra stuff I have. But if you ever have problems with it, you can look in whatever window you opened up the server into, and you might be able to find out what the problem is. Now I'm going to save this notebook, and I'm going to use only the Jupyter commands here. The commands up here are for the browser. I'm going to ignore those. So I'm going to save file, and I'm going to save this as, and I'm going to give it a name. I'm going to call it demo notebook. And the extension for a notebook is IPYNB, right? IPython notebook. Ordinary Python files have a .py extension, but these want to be an IPYNB. All right, now this is pretty cool. I'm going to do one more thing here, and I've got some notebook extensions. They're kind of beyond the scope of the class, but down the road, I'll show you how to use them. I'm going to get rid of this table of contents, like so. But I will just point out there are extensions you can use for a notebook. They're really easy to add. One of them is called AutoPep8. Remember a minute ago I said there's some things that'll let you correct your code as you go. Well, the notebooks have that. So if I have all the right software installed, I can just click on a button. I can get my code formatted correctly. Okay, but what I want to get rid of here is the table of contents. So I just uncheck that. And if I reload this notebook, the table of contents should go away. Okay, and this just left a blank cell. Okay, so what are we looking at here? Okay, we have a client, right? Our browser. Our browser is talking to something. What's it talking to? It's talking to a version of Python. In fact, it's as though it went into the command line, like so, and it typed Python. Okay, but it doesn't show us all this stuff. This instance of Python, this Python kernel, K-E-R-N-E-L, is just behind the scenes. Okay, but we can talk to it. We can't talk to it quite as interactively as we can at a command line, but what we can do is we can type in Python code. So we can type in something like a string, like so. And we can run it by clicking on run. So what it did is it took this line of code that we wrote in our browser, it bundled it up and it sent it to Python under the hood. It's running silently, it executed it, and then it brought back the results of executing our line of code into our browser, like so. So it works just like a command line, with the exception of the fact that you have to take an extra step to make it run. So if we wanted to give our string a name, we could call it a dog. And let's use a single quote this time. like so. Now, if we run this, we're not going to return anything right away, right? But we have access to it just as though we did the same thing here. So if we said dog equals Quinn the Husky. Now this kernel is separate, right? It's got nothing to do with our notebook. It's just something else we're playing with. You can have one kernel for every core you have on your CPU. It's not going to return anything. Okay, so we say dog now, it remembers dog. Now, our notebook works the same way. If we just said dog now and run it, it'll come back with the dog. Okay, so we've assigned a name to a string object. So we can type in like type of dog and we can find out what it is. We can find out how long the string is by asking it to give us the length, like so. Tell us it's 15 characters long. We can say help on a string, and we'll get the same thing back, okay, as we would on a command line. Now there's some differences and some huge advantages to a notebook, especially while you're learning. One of them is this cell here is Python code. We know that by looking up here. It says code. That means when we run it, it'll execute as Python. All right, but you can put in different kinds of cells. So if we wanted to say insert, we can put in a new cell here above it. And instead of making the cell a code, we can call it markdown. So what is markdown? Markdown is just a real simple way to format text. You can go to help, and there's a markdown tab, and you can learn how to do markdown. It's really pretty simple. You can also get help on how to use the notebook, and you can get a Python reference. So you can get all kinds of cool information using the Jupyter Notebook version of help. But if you have a markdown cell, you can do things like put a single quote, and you can make a heading. It's just a real simple markup language. And you can put in any number of these, like so. It'll kind of show you what it's going to look like. But when we execute this, you can see how nicely formatted it is. Now who cares? Well, you care. Because if you want to make some notes, you can put in titles like that. And if we want to insert another cell above this one, we can maybe make another markdown cell. And we can say working with strings. Okay. So these are just individual cells. You can change them, you can get rid of them, anything you want to. And you can also embed comments. Like we can just say here, simple string at command line. And the interpreter will ignore the pound sign and everything to the right of it. So we've just embedded our class notes in here. And here we might want to say assign a name like so. All right, so if you use a notebook when we get together again, you can code along with me, and you can have a permanent record of everything you code. It's okay to work in a command line or in a PyCharm file or whatever. But if you work in a command line, you're not going to be able to retain a record like this. Okay, so I'll just put in one more thing here. Observe output of the REPL. And we'll say read, execute, print. And we'll say dom. Okay, so you can make notebooks that are going to be really useful to you in the future. You can save your notebook. You can send your notebook to somebody else. You could put your notebook onto an external server and give other people access to it. So they'll have access to your notebook. And if you want to show stuff off to your colleagues and you're working remotely, as long as you have access to the same server, right? We don't have to be on localhost. We can be anywhere in the world. As long as you have access to the same server, you can share your notebook and you can get help or anything else you might want to do. Okay, that's kind of the pitch for notebooks. Another cool thing is you can, so here we've learned how to get help, right? We don't necessarily want to look at all this stuff. You'll recall that this is really long. Well, you can come up here and say cell. You can just clear out all your outputs. So you don't have to look at it anymore. All right. So I'll share this notebook with you in the chat after class, and you can play with it. I'll put in a couple more notes here. So you can ask what type of variable is. And variable is really object. Okay, you can use type and how many elements are in it. Okay. And this is a way to get verbose help. All right. Now, one thing you might have seen going by is we have a string, and let's make a string that says Scotland. There's only one T in that. Okay, so there's our string. Okay, that string we can iterate through it. Okay, so we can find out, I want to really print the character. So we can find out what each of the elements is. All right. Now, if we're printing stuff, we can print lots of things. Okay, here we've just printed a single character here, but we could print a bunch of things. So if we wanted to print the character and then the type of the character, right? What kind of variable is it? We could also put in type of the character. And print is smart enough to try to do this sensibly. So every time we print something, it'll automatically put in a carriage return by default. And if we have lots of things, it'll put a space in between each one by default. We can correct that default behavior, but this is what I wanted to show you. This variable here, Scotland, is a string, right? And we can come back here and print that out. We can see the dog is a string, Quinn the husky. And S is a string, and each of the characters in S is a string. So Python does not have a character variable type like some languages do. Some languages say that this is a character and this is an array of characters. Python kind of thinks of it that way because you can iterate over the array pretty easily, but each individual element of this is a string. So we saw a little bit earlier that that we could use a method like lower on a string, and it'll give us a lowercase version of that string. If we just had a single character, like let's call it X, we could make an upper version of that. So in other words, when we typed help string and we found out all the different things we could do with this string, well, we can also do all those things with characters, because characters are just really short strings. They have all the same methods and properties. You'll hear that a lot. A method is an action. So it's like a verb in a human language, and a property is like an attribute. So it's sort of like a noun. All right, so my dog Quinn is a husky. So he's got the property of being white. My dog Quinn likes to go on walks. So walk is a method known to a dog, and a dog can execute a walk. And that's different than having the property of being white. So the stuff you have access to in terms of the toolkit that comes with the string is going to be broken up into properties and methods. All right. Now, you might want to know a little bit more about strings. One thing you can find out about any string is what the names of the methods and properties available to it are. We saw we could do help, and then we could execute help on some object. You can always do that. And that's a pretty good way to learn how to use stuff. If you just want to see what it has access to, another really good command to use is dir. And what dir will do is tell you all the properties and methods available to some object related to Python. So if we wanted to ask it for the methods and properties with X, we can just give it this syntax. And what we'll end up with is a list of stuff. And a lot of these will look familiar maybe or not from when we asked for help, because help kind of described all these things. But this just gives us a real short synopsis of what it is we can ask it to do. Okay. And we won't go over all these. I'd encourage you to explore them, but you've got the possibility to capitalize it. Okay. You can test whether it ends with a character sequence of some kind. You can ask it if it's got only alphanumeric characters. You can ask if it's trying to represent a decimal number. You can ask if it's lowercase, all kinds of stuff. So you can, if you have a string, you can ask it lots of questions. They all begin with is. You can format it in different ways. You can interrogate different bits of it, like ends with, and there's another one starts with down here. Okay, and you can typecast it into different kinds of objects, some of which we'll talk about later. Now, I don't want to bog you down with a lot of detail here, but what I do want to do is show you, even for a very humble object, like a string, you can do a lot to it. The other part of that is you don't have to do a lot with it, right? The stuff in Python just works, right? So you can say print, and you can say X, and you can say dog, and you can say, what else? S. We created a variable called S. And it'll be happy with all that, and it'll just do stuff. So one of the beauties of Python is that you can operate at a very, very high level. And even if you don't know what you're doing, or you're just learning the language, Python will just work for you. If you want to start digging around, you can use type. You can ask it for its ID, tell you where it lives in the memory. You can use methods like upper and lower case. And this requires like no particular training. If you are in the process of learning and you use a notebook, well, you're going to walk home with all this stuff, right? And you can kick it around and you can play with it. Okay, questions so far? All right. So we started to introduce a little bit of syntax here, and we'll show you more syntax as time goes on. But our humble object here, the string, the string is what's known as an iterable object. And what does that mean? That means we can loop over it. Okay. And the basic syntax for looping on any kind of an iterable object is you can use the word for, and then you can make up a variable. You can have a made up looping variable. And then you can say in, and then you can say some iterable object. Okay. And then a colon, and then an indentation, okay, so it's indented, and then anything you want to do. So that's all you have to do to loop in Python. So I'm going to comment all this out so you know it's not code. So as we saw, we could say for, and we can say a made up something in S, and here we can do anything we want to do. I'll take this opportunity to do as little as possible. And I'm going to introduce you to a keyword called pass. What does pass do? Absolutely nothing. Because Python, for a looping expression or any other bit of Python, does not have braces. Okay? Python relies completely on indentation to separate code blocks. Okay? So here we have what's called the header. of an expression, and you'll have a header and like a while statement, or maybe a class, or maybe a function that'll be more meaningful to you later. But if you have a header expression to start off some kind of an operation or some kind of an object, beneath that you'll have what's called an indented suite, which is a real fancy name. All that means is the stuff underneath your header has to be indented. So what we did here for every object in this thing we can loop over, we went over it one at a time and we did absolutely nothing. So if you need an indented suite and you don't need to do anything with it, you can use the keyword pass. All right. Now, this made up variable can be anything. We could just say for, it's helpful if it's meaningful, but it doesn't have to be. But I might put individual character in S, and I might say something like, hey, and then we can put commas, and we can put anything we want to here. So we can put individual character, like so. And that will be sufficient to loop over every character in S. Now, just for comparison, and let's label this for loop example. Okay, now for comparison, we do not have to do for I is equal to 0, and then figure out what the length of S is, and then do I plus plus, open bracket, printf with a format string, and then say something like I. All right, we don't have to do any of this garbage in Python because an iterable object knows, among other things, how long it is. Oops. I'm just going to comment this out so when you get it, you won't be confused. It's going to add another cell here. So if we wanted to say the length of S, Python already knows about it. Okay, so we don't have to ask it again. We don't have to do silly stuff like incrementing a counter, right? Because Python knows how to do that already. Okay, we don't have to, actually, in some languages, we'd have to say int, for int I equals 0 to the length. We don't have to declare our variable types. Did you notice that? We didn't have to say S is a string or dog is a string. The Python interpreter just inferred that, right? So that's another thing. Python infers data types. So we can say something like another data type is an integer, like so, and we can ask it to print A and the type of A. Python's completely happy. It knows it's an integer. We might say B is 1, 1, 2, 3 dot 1, 2, 3. And we can ask it for what type B is, and it knows it's a floating point number. Okay, we didn't have to tell it. And in fact, Python is so liberal that we've already defined A to be an integer. Well, if we wanted to say A equal, I am now a string. We can ask Python to do that for us, and Python will be completely happy, right? It doesn't care that we've recycled the name A. It'll just go ahead here and create a new inference. It knows that's a string because it's in quotes, right? And it'll very nicely and unbidden store the name with the appropriate variable type. So anyway, we're about done for today, but I hope you've come away with a notion that Python is really easy to use. We can just give it something like a string. It'll know that it's got a string. If it has a string, it knows all kinds of stuff to do with it. We can make strings any way we want to include singular double quotes, lots of lines in the string. It'll report it just in the REPL, and it'll print it appropriately using any control characters, any special characters we have in there. And we basically don't have to lift a finger to make that happen. Okay. We've looked at a couple tools, the command line and the notebook for handling Python. They both work pretty well. The notebook is a way to preserve a record, and I hope you'll consider using it. If you're going to write scripts in PyCharm, that's fine too. You have files you can go back to. And the command line is always available to you, of course, if you want to play with it. So we're about out of time. Does anybody have a question I can answer right now?
I have a question.
Yes.
How does it work with the certificates with these classes? Like, how do you guys know that we've completed these, and how do we have access to those?
That's above my pay grade. I'm an instructor. Is somebody on the call that would know that answer, or shall I research it and come back to you? All right, that is a research question. So I'm going to make me a note. So I remember. And I'm going to save this. And the last, or any other questions I should ask? Okay, so my last responsible act here is I'm going to take this notebook and I'm going to paste it. Let's see, documents, where did I put that? I think I put it in documents. Pat files. And no, what did I call this? I call it junk. No. Okay. In a couple of minutes, I will figure out where I put this, and I'm going to find that out by looking here at my notebook. I'm going to make sure I save it. I'm going to kill that with a Control-C. Okay, then I'm going to paste it in the Slack channel we're using. If any of you have a problem getting a notebook installed or getting it working, let me know in chat. I'll look at it later this afternoon. And hopefully we'll be able to get you up and running with it and or VS Code by the next session. Okay, so for now, I'll bid everybody adieu and wish you a good rest of the weekend. And I'll look forward to seeing you in our next session.